Okay, let's go over the answers to today's test. The test you took the other day on scientific notation and laws of exponents. So let's start out with number one. What is the rule when I multiply things with the same base? Add exponents. Okay? And so this is the work I'd like you to show. 4 to the 3 plus 5 is 4 to the 8. And then that would make sure that you got it right, D. The second one, just like division is the inverse operation of multiplication, that means that when I divide exponents, instead of adding when I multiply, I subtract when I divide. Makes sense, doesn't it? Good answer. So 10 to the 9th, C. Okay? Any questions so far? Hopefully everybody got the first two right. If you didn't, hopefully you know why. Okay, I'm going to pause right there. So now I'd like you to write, if you got it wrong, or if you got it right, you can do this too. Write the page number where your flip book is, because that's where you have the rules of what to do when you multiply things with the same base or divide things with the same base. So whatever page number in your book has a little flip, the purple flip page, just like Brian's right here. What's that page number? So you guys need to start utilizing this. It says right there, when multiplying things with the same base, add exponents. If you got anything wrong, it's in your toolkit. Okay? That's on you. Alright. Any questions? Everybody got that? Okay. Number 3. What do we do when we are multiplying two numbers together that have things with exponents? Well, we multiply the numbers just like we normally do. 3 times 4 is 12. Okay? And then we multiply things with the same base. And we know that when we do that, we can add exponents. So the 4 plus the 3 is 7, and I get 12x to the 7. Okay? So we multiply like numbers just like normal. And then when we multiply things with the same base, we add exponents. What is the rule when we divide? We subtract exponents. This would be k to the negative 4 minus 1. Whenever we subtract, we're always subtracting in the numerator. Okay? This is where I use my integer skills. Plus a negative, oh, that's k to the negative 5th. Oh yeah, there's a negative exponent rule that we added in our notes. To make a negative exponent positive, I put it under 1. That's why the answer is A. Okay? When I put it in the denominator, it becomes positive. Let me show you why. Let me show you why, Nathan. Let's take a look at k to the negative 5th. If I multiply, can I multiply anything in math by 1? Yep, I can always multiply by 1, right? So, am I multiplying this by 1? Is anything divided by itself 1? So this is just another way of writing 1, right? Okay? What happens when I multiply that out? I get k to the negative 5 plus 5 is k to the 0 over k to the 5th. What is anything to the 0 power? 1. Oh. That's why when it's in the numerator and we put it under 1, it makes it positive. That's the math to show. Pretty cool, huh? Yeah. I think so, Nathan. Okay, number 5. When I have a power to a power, that is the third thing in your flip chart. Write the page number. What do I do to exponents? Multiply. Multiply exponents. Or distribute the exponent on the outside by the ones on the inside. 4 times 2 is 8. Good. Escape. Okay. Number 10. Sorry, we're going a little bit out of order here, but we'll go back to that next column in a minute. Number 10, we are going to go ahead and distribute the power. First thing when we wrote step-by-step how to do this in our notes, so go to your page, find the page, where we wrote step-by-step how to distribute. We put, what do we do if there's no exponent? Add a 1. Very good, Brian. We put a 1. Okay? Because then I know that when I multiply, 2 times 1 is 2. 2 times negative 3 is negative 6. 5 times 1 is 5. And 5 times 1 is 5. Now I'm going to do a little simplifying. I have 5 squared, or 25, times 2 to the 5th, or 32, times x to the negative 6 times x to the 5th. Notice I'm taking my time to show the steps to make sure I don't make a mistake. Now I can multiply 32 times 25 and get 800. And then I get x to the negative 6 plus 5. Because when I multiply things with the same base, I add exponents. What's negative 6 plus 5? Negative 1. Okay? And then to make a negative exponent positive, I put it under 1. I want you to think of this, and we've talked about this, as this times this. Right? Therefore, when I put the negative x in the denominator and make it positive, this is still in the 800 still in the numerator. And that's the answer. You multiply the exponents? Good, you know what you did wrong. I bet you won't make that mistake again. But that's what we're talking about. You have to know when to add, when to subtract, when to multiply. Okay? Did you have a question? Yeah. Okay. Do you need more time? Okay. Let's continue, shall we? Okay, so this one was supposed to be the negative 9. Sorry about that, but everybody knew that after we talked about it. So what is when I multiply? I add exponents. What's 11 plus negative 9? It equals 2. Okay. Number 6. What are we doing? What does a fraction bar mean? It means divide. So 42 divided by 7. And then we have m to the 6 over m to the 4. So when I divide the numbers, I just divide it like I always have. That's 42 over 7 reduced to 6 over 1. And then I have m to the 6 minus 4, because when I divide things with the same base, I subtract exponents, which equals 6m squared. Okay, write that in ink if you missed it. The next one is, we're just multiplying the numbers. Negative 5 times 2, negative 2 is 10. When I multiply things with the same base, I have p to the 3 plus 6 is p to the 9. A lot of you messed up on this one, but it's just the integers. Okay? If you took the time to show the work, you would get b to the negative 7 minus negative 3. And minus negative equals plus positive, which gives me b to the negative 4. How do I make a negative exponent positive? Put it under 1. Does it become positive when I put it under 1? I was really surprised. Some of you put it under 1 but left it negative. The whole purpose to put it under 1 is to make it positive, because all answers needed to have positive exponents. Okay. If we want to know how many times larger something is than something else, we want to take the larger and divide it by the smaller. So that's just a word problem to show that you understand how we can use scientific notation to do computation. That's kind of a good rhyme there. Okay, and I just go 8 divided by 2 is 4. So when we had steps in scientific notation in your toolkit, so mark that page. 8 divided by 2 is 4. So the first thing I do is I divide my coefficients. So 8 divided by 2 is 4. My second step is to subtract exponents, because when I divide, I subtract exponents. My third thing to do is to write the product, and that gives me 4 times 10 to the 4th, right here, right? 4. And then I have to ask myself, is that answer in scientific notation? And the answer is yes. Okay, page 1 done. Any questions on page 1? That's down. Okay, page 2. If you want to find out how many times smaller something is, you want to divide the smaller by the bigger. Okay, same dealio. 1 divided by 4 is 0.25. Step 1. Step 2 is to subtract exponents. So I'm going to go negative 7 minus minus 6, sorry. Negative 7 minus 6, which is negative 13. So I have 0.25 times 10 to the negative 13. Last step is just in scientific notation. No. So I have to make this bigger by 10 or multiply by 10. In order to, if I do that, then I need to balance it out or do the opposite with my power of 10. So I'd have to take 1 away, and that's going to make this 2.5. And then negative 13 minus 1 is negative 14. B. Okay. That was 12. 13. Question? Okay, sure. All right, 13. Let's do this. So now we have an amount of soda in gallons. We have an amount of seconds, and we want to know how much soda is drunk. If the game lasted 24 hours, that's a bit of a stretch. It's a huge stretch, but I just had to do that to make this work. So, anywho, I'm just going to multiply them together. We know that when we're multiplying things in scientific notation, we multiply the numbers as usual, and we get 12.9. We add the exponents. 4 plus 4 is 8. We write the product. Then we see if it's in scientific notation. We say, wait a minute, it's not between 1 and 10, so I have to make it between 1 and 10. So I make this smaller by 10. So I have to make this bigger by 10, 110, and that adds an exponent. If I make it smaller, it subtracts. If I make it bigger by 2 places, I subtract 2. If I make it smaller by 2, I add 2. So it's just, you're doing the opposite. You're balancing it out. That's the way I like to think about it. Okay, number 14, instead of multiplying, we're dividing. Everything's exactly the same, except we divide the numbers, and we get 5. And when we divide, we subtract exponents. So we get 5 minus 2 is 3. Done. That one was supposed to be pretty simple. Hopefully you got it right. We need more time. Okay, number 15. Now, this is when it got a little tricky. This is the only thing, but we spent a lot of time on this. And we also, again, wrote down steps. You need to make powers of 10 the same. Okay? If I make this bigger by 10 by adding an exponent, then I need to make this smaller by 10 by moving it 1 to the left. And and then this one stays as is, right? Because it's already times 10 to the 7th. So step 1, make the powers of 10 the same. That's the tricky one. The rest I can do on my calculator. What's 0.941 minus 2.59? Well, this is a good time to use a calculator. Why not? We already know how to add and subtract decimals. Let's speed it up and use our calculator. 0.941 minus 2.59. Negative 1.649. Okay, and then the power of 10 stays the same. Is it possible to have a negative number in scientific notation? Sure. Scientific notation is usually between 1 and 10 times 10 to a power, but it also, Bobby, can be between negative 1 and negative 10 times 10 to a power. Good. Awesome. If you did it right, it still should work. Want to do it? Let's do it. Okay. So make the 7 a 6 over here. I already did. So I did. Okay, 16 is similar. We are going to make the powers match. So if I make this smaller by 3 places, so if I make that 10 to the 3rd, I need to make this bigger by 3. So I go 1, 2, 3, that becomes 6,000. Okay? And then plus 2 times 10 to the 3rd. Now, that's the hard part. Now I just add 6,002. Powers of 10 stay the same when I add or subtract. And now I have to make it in scientific notation. Make it smaller by 3. I need to make this bigger by 3. 6.002 times 10 to the 6th. If you guys were to practice anything, I'd say across the board, it's adding and subtracting. And I told you that going in. That's the one that requires. It's not necessarily hard. It's just understanding that If you make one part of the scientific notation positive, one has to go the other direction, or vice versa. And that many places, or that many tens, multiplying or dividing. Okay? Number 17. This one. This is a great question because you'll see a lot of these just like that in the square balance. Okay? So, what do I do here? Some of you may have just simplified inside first. Add the exponents. So 3 to the 5 plus a negative 3, right, is 3 squared to the negative 2. Step 1. So parentheses, PEMDAS, doing the parentheses first. Now I distribute, because when I have a power to a power, I just distribute, and I get 3 to the negative 4. Oh, D's one of them. Okay? What is 3 to the negative 4th equal to? 1 over 3 to the 4th, which is 1 over 81. What is negative 10 plus 6 here? B, C, and D are all right. That was a three part. That was worth 3 points. Okay. Number 18. What would I add? This is just basically when I multiply things at the same base, I add exponents. So it's basically saying 5 plus n is 11. What's n? Bobby, do you have a question? I can't wait. Does anybody still need these up here? All right. 19. What? This one, all you have to do is type it in your calculator. Okay? And what did you get on that one? Okay. Most of you type that in right. Believe it or not, some of you missed these. If I'm ever typing something in a calculator, I always do it twice. It's really easy when you have a lot of zeros to miss one and then it's wrong. And this was 2e to the 2.3. Okay, which just means 2.35 times 10 to the negative 10, right? Okay. Everybody good on those? Most of you got those right. She just had to put them in her calculator. Okay. Well, what would this be in standard form? I like to do these in scientific notation first, because that's the easy one. Negative 4.1 times 10 to the 8. Now, a positive exponent tells me to go right. Okay? So I'm going to go right 8 places. 1, 2, 3, 4, 5, 6, 7, 8. What goes in those blanks? Zeros. Okay, what does that leave me with? I'm going to write my answer above because I don't want to see this in your answer. Some of you got this wrong because 1, 2, 3, 4, 5, 6, 7. Because you lost a zero somewhere, or you left a decimal here, or you can't do that. Okay? And then I need commas. A lot of you I put in commas because I can't tell if it's right until I put in the commas. It's negative 410 million. Okay? That's the answer in standard form. Page 22, again, I do scientific first. That's the easy one. And then the negative fifth just tells me to move it 1, 2, 3, 4, 5 to the left. Put in zeros. So I'm going to get 1, 2, 3, 4 zeros. And then 1, 7, 3. Got it? All right. How about over here? What happens when I divide things in scientific notation? Divide the numbers. What do I do? The exponents, subtract. Negative, or minus the negative is plus the positive. 5 times 10 to the negative 2. Done. Scientific notation. Anybody made a silly mistake so far? Raise your hand. Anybody made more than one silly mistake? And a lot of you I could probably keep on it. Okay? So hopefully you're going to learn from it and be good on the retake on Monday. Yes. Okay. Remember, not yet. We divide numbers. We don't subtract numbers. This is 7.5 divided by 1.5. When we divide numbers like we always have. We subtract exponents. I know. I recall seeing your answer going, I bet she subtracted instead of divided. Which was one of those moments where you just kind of weren't there for a second. You got to be there. Okay, B. Multiply. What's that multiply to be? 6.3 times 2.2. Well, let me tell you. I'm faster than you, I guess. 13.86. Okay? 13.86 When I multiply things with the same base, what do I do to exponents? 12 plus a negative 10 is 2. Is that a scientific notation? No. If you didn't recognize that, you lost a half a point. Okay? To make it into scientific notation, I have to make it smaller by 10. So then I have to make the power of 10 bigger by 10, 110. So I have to add 1 exponent. Yes, Carson. If it can't wait, because it's really important to go through the rest of this. So I'll leave that up to you guys. Right here, I just need to make the powers of 10 the same. So if I make this to the 11th, I need to make it smaller by 3. So it'll be 0.00523. And then this one will be the same. Now I'm going to add and get 4.87523. That's it. Done. Okay, pretty basic. Okay, same dealio here. We subtract, so I need to make the powers the same. If I make this smaller by 2 tenths, to make it the same, I need to make this bigger by 2 tenths. Remember, you can do it either way. I just chose to do it that way, just because that's what came to my mind. 110 minus 3.7. 106.3 times 10 squared. Is that between 1 and 10? No. I need to make it smaller by 2. So I need to make this bigger by 2. I remember doing about 20 of those problems. You should. Okay, here, power to a power, I multiply it. That was supposed to be really easy. It did say to evaluate or multiply it out. Okay, so what is 8 to the 10th? I'm going to use my graphing calculator for this one. 8 to the 10th power is 107,374. 1824. And I only know how to say that when I put in the commas from right to left. 1,073,741,820. Okay? A lot of you made a mistake on this one. The power on negative 5 is 1. So if I do a negative to a power, I always need to use exponents. Parentheses. Then I know a negative to an even power is going to be positive. So 5 to the 6th power is 125. What is it? 15,625. W to the 18th. All right, last page. We're going to make it. A lot of you, this one blew me away. Okay. Okay, number 26. Remember to put an exponent on everything on the inside, so let me rewrite that. 0.2 to the first, x to the first, all to the fifth. So I need to distribute that power, just like it says in our toolkit. So that gives me 0.2 to the fifth, x to the fifth, and then I just go in my calculator, my graphing calculator, 0.2 up the fifth power, enter. Do that, and you get 0.2 to the fifth, enter. And this is what I get. If you don't know what that means by now, you should miss the problem. Because you should know that's 3.2 times 10 to the negative 4th. That's what this is all about, this whole test. And that just means I need to move the decimal 4 places to the left. And that will be that. You know that. I mean, that's not the easier one. But you know that that's what that means. That's why we had all those questions on the previous page. Okay? Okay. I'm glad to hear those. That means you're actually learning from your mistakes. This one, I need to distribute my power. 3 to the 4th, r to the negative 12, times 8 squared, r squared. Okay? Now I need to do some simplifying. 81 times 64 times r to the negative 12 times r squared. 81 times 64, I'm going to do on my calculator, and I get 5184. 5,184. When I multiply things with the same base, I add exponents. So I get negative 10. Can I have negative exponents in my answer? No. So I have to put it underneath. Done. Okay. And last but not least, I'm sure you all know what the bonus was. It's asking for the difference. And everybody in here knows that difference means subtract. If I'm finding the difference, I'm going to take the bigger minus the smaller. Doesn't really matter. Are the powers of 10 the same? No. So if I make this smaller by 10, actually if I make this bigger by 10, let's watch please, we're almost done. If I make this bigger by 10, I need to make this smaller by 10. Hard part's done, the rest I can do on a calculator. Okay, I can go 3.7, I'll do it on my graphing calculator for sake of time, minus 0.26. And then powers of 10 stay the same. Okay, so you have 4 minutes to not put your stuff away. I'm going to come around with, I'm going to